Welcome back. In this lecture series, we are going to see about the electrical braking system. Before moving into the various steps of electrical braking system, we should know the introduction of electrical braking when compared to the mechanical braking system. Okay, let's move on to the topic. So, what is electrical braking system? Now, you may imagine in our domestic application like home or office or wherever we go, always we need air circulation in order to avoid this sweating. Am I right? So that just when we are moving into when we are entering into the home or office, just our first action is switch on the fan. Am I right? Yeah, definitely. Everyone is when he is entering into the room or office or wherever he go, first he need the air circulation in order to avoid the sweating issue. Okay. So after the usage of fan, I'm leaving from the that particular office or area, whatever it may be. So immediately I want to switch off the fan. When I switch off the fan it doesn't come to its original position. It's not come to its original position immediately. When the fan is switched off, again the fan is slowly rotating. The speed is always gets decreasing. When the speed is slowly reduced, after a fraction of time, it may be 20 seconds or 30 seconds or it may be 40 seconds. It is based on the speed of operation during the running time. So the speed it comes to its original position, that is standstill position. Okay. So when the fan is disconnected from the main supply or switched off or it may be some interrupted is occurred, but the the fan will rotate for some other time. It's because of moment of inertia. It is because of the moment of inertia. Okay, am I right? So here we can't achieve the immediate stopping. Here we can't achieve the immediate stopping. It takes some more time. It's because of due to inertia. Okay. You can consider another example for another application. Now you are driving a car or it may be a two-wheeler, etc. Now you are traveling from one place to some other place through road. Now you've seen in front of us one small girl, one child or one other old man is walking, is crossing the road. So we feel like if you are continuing this speed, definitely the accident may occur. The accident may occur. So immediate reaction or action with respect to us, we have to apply the braking. We have to apply the braking. Now I see that particular person, so the braking is applied before 20 meter or it may be 30 meter or some distance. I am applied the brake. Now you can correlate with the fan. When the fan is disconnected from the power supply, the fan it rotate for another some duration, for another some time because of moment of inertia. The same condition is applied in an automobile. If the braking is applied, again the two-wheeler or four-wheeler it can travel for another 20 meter or 30 meter. Means what will happen to the human being? Just you can imagine what is the case. So definitely the accident will occur. Definitely the accident will occur. Am I right? Yeah, it's because of moment of inertia. So then what is the purpose of applying the braking? There is no use in this case. Am I right? So wherever in this particular case, for example, the same vehicle, it may be two-wheeler or four-wheeler. Somebody having Royal Enfield Bullet and few of them having Pulsar and few of them having TVS Excel. You can compare this or R15 like that. Just you can compare these vehicles. During the feedback which we are receiving from the youngest generation, the students from the youngest peoples, everybody will vote for R15 or Royal Enfield like that only. No one will prepare TVS Excel. May I know why? Because the R15 Royal Enfield Pulsar, this gives high speed. That is nothing but it gives. What is that? Can you comment what is the reason? Because it's called pickup. Okay, it is based on the CC. It may be 110 cc, 150 cc, 175, like 220 cc, like that. Okay, so it is depends on the pickup. So the R15 Enfield, and it gives the on Pulsar. You can compare. The pickup is very high. When Excel is very low pickup. When we are starting the Excel, when we are giving the full accelerator, it's slowly moving. After a certain duration only, the speed will be increased. But it is not equivalent to the Pulsar, which is not equivalent to the Royal Enfield, and which is not equivalent to the R15. So it gives very slow pickup and slow speed. Okay. When we are moving to the Pulsar, when we are compared to the Pulsar and the Enfield, the Pulsar gets low pickup when compared to the Royal Enfield, because the Royal Enfield, it may be 350 cc like that. So it gives more pickup and more speed when compared to the Pulsar. So everybody, they are looking for the good pickup, high pickup. Am I right? Okay. So my point of view, whether the starting is more important or the braking is more important. Can you say which one is more important in an automotive industry? The starting or stopping, which one is more important? Put in the comments section. Definitely, the braking is more important when compared to the starting, because the starting, it may take 20 minutes or 30 minutes or 40 minutes, or even it may be 1 minute to pick up into the normal speed. That's not an issue. But the braking should be more important. The braking is more important than the starting. The braking is very, very important. Okay. So, in fact, the quick stopping of the motor, is more essential, is more important than quick starting. And few of them, they are working in an industry. There is a rolling mill, paper rolling mill, or some other industry. And one man, and his hand is locked inside the machine. The machine gets moving. So the hand will go inside, so that we have to cut the hands. If you are switch off the machine, it may take another 20 minutes or 20 seconds or 30 minutes time to stop the machine. The full hand will be gets damaged. It will get into the fracture. The hand will completely goes out. So in this kind of industry, the braking is more important. If any kind of emergency, immediately we have to apply the braking. So with the help of braking, immediately the motor comes to its rest position. It is just like disc brake. When we are applying the brake, immediately it comes to its rest position. It's more important. So that only we can able to protect the human being. You can able to protect the human being from the heavy damage in a lot of the industries. Okay. So, and also the braking system should be more reliable, and it is very quick in action. Very quick in action. Okay. Yeah. So normally there are two types of electrical braking. One is called electrical braking and another one is called mechanical braking. So what is the difference between these two braking? First one, the mechanical braking. So here just you can consider a two-wheeler is in running condition. When we are applying the brake, the vehicle will stop there itself. The vehicle will stop there itself. Suppose without applying the braking, just if you are switch off the vehicle, it will not stop there itself. Again it goes another 20 meter or 30 meter. So after that only the motor, the two-wheeler will come to its rest position. Am I right? So we are switched off before itself, but it again travel for another 20 to 30 meters. Am I right? So this is moment of inertia. So while applying the mechanical braking, just like brake shoe, this is a rotary moving parts, and this is the brake shoe. So the brake shoe will be attached to the brake drum. So the amount of energy which is stored in a brake drum, it's because of mechanical braking. All the energy which is stored in a brake drum, that will be converted into heat, that will be dissipated as a heat. This is the mechanical braking. So the amount of energy in the brake drum, that will be completely dissipated as a heat. The heat is nothing but waste one. But if we go for, before that there is an assessment. Which of the following is best braking method? Which one is the best braking method? Friction. The second one, electromechanical action. And third one, eddy current. And fourth one, electric braking. Okay, put your answer in the comment section. So next one, electrical braking. So here in mechanical braking, the amount of energy stored in a brake drum is converted into heat, waste. But in electrical braking, the amount of energy which is stored in a drum is converted into electrical energy. That is nothing but useful energy. If you want to use it for the storage or the illumination of lamp or some other electrical load, you can use it. Otherwise, with the help of resistance, with the help of rheostat, you may convert the electrical energy into the heat energy. So one thing, with the help of mechanical braking, so the amount of energy is converted into heat only. But in electrical braking, the amount of energy can be converted into electrical. If you want to use, you can use it. Otherwise, with the help of resistance or rheostats, that can be dissipated as a heat energy. That is also waste. You may need, you can use. Otherwise, you can dissipate as a heat energy. Okay. So what is the advantage and disadvantage of the electrical braking over the mechanical braking? Okay. So the first one, the electrical braking, with the help of electrical braking, we can able to control the speed of the motor. And also the bringing the motor to the standstill condition. But in mechanical braking, which is used for the emergency purpose, it can be used for the emergency purpose to stop. Okay. So here, with the help of electrical braking, we can able to bring in the motor to the original position. Also, we can control the speed. But in mechanical braking, so under emergency purpose, we are applying the braking. One thing. And the second point, the electrical braking is very smooth and it is very comfortable one. But the mechanical braking, it is not comfortable because it is very rough. Okay. And the third one, no wear from the electrical braking. There is no wear and tear in the electrical braking. But in mechanical braking, when the brake shoe is applied to the brake drum, there is a wear and tear in the mechanical braking system. Okay. And in electrical braking, the stored energy, the amount of kinetic energy can be converted into useful energy that can be used for the return to the main supply. But in mechanical braking, it is not possible. In mechanical braking, it is not possible to produce the useful energy. It is one waste one. And the next one, the electrical braking can be used as a safety device. It is not used for the safety device, but the electrical braking, but the mechanical braking can be used as a safety device. Okay. So in electrical braking, there are different types of braking are there. That is nothing but rheostatic braking, plugging, and regenerative braking. So like the few types of electrical brakings are there. But in mechanical braking, so with the help of drum brake, disc brake, band brake, okay, so like the few of mechanical braking is available in there. So this is the second assessment. The DC motor is still widely used in traction due to its excellent braking property. Kind note, and DC motor, they are not specified whether it's shunt, series or compound. Generally it is called DC motor. It is still and widely used in traction. That is nothing but a railway. It's because of excellent only the braking property. So only with respect to the braking property, the DC motor is used in traction, whether it's true or false. Okay, put your answer in the comment section. Okay, and these are the reference papers and reference books for the introduction of electrical braking. Thank you.